Welcome to our fourth video tutorial about conducting pilot experiments to gather data for industrial scale system sizing. In this episode, we will discuss membrane cleaning. After a pilot trial, it is important to clean the membrane to ensure that the next trial is done with proper starting conditions. Let's look at a typical clean-in-place sequence. The first step involves completely draining the system to remove the product from the membranes. The membranes are then rinsed with water to remove remaining traces of product. The first washing is carried out with an alkaline solution such as sodium hydroxide or a chlorinated alkaline solution such as sodium hypochlorite. The aim is to remove any clogging due to organic compounds. If possible, this step should be done at high temperatures. The membranes are then rinsed with water to neutralize the washing solution. Depending on your application, a second washing with nitric acid may be required to remove fouling from mineral compounds such as phosphates or calcium. Finally, the acidic solution is neutralized with one last rinse with water. A few tips for your CIP procedure. First, use chemicals in the proper sequence. Depending on the application, the sequence may differ and only some steps may be necessary. Second, a slight overdosing of chemicals is recommended. Third, proceed to CIP at the adequate temperatures and be sure to stay within the acceptable limits of temperature shocks. In order to maximize the efficiency of CIP procedure, the most important parameters to be optimized are the chemical dosage, the cleaning time, and the temperature of the operation. At the end of the CIP procedure, proceed to water flux testing to evaluate the efficacy of the cleaning. A corrected permeate flow in standard conditions of temperature and pressure can be calculated from the measured data with the following formula. These values can be automatically calculated using NovaSIP logbooks. They provide an easy benchmark and tracking of cleaning performances. At the industrial scale, one shall proceed to membrane cleaning at the end of a batch, either for sanitary reasons or when the performance has deteriorated below an acceptable level because of fouling. This membrane cleaning operation is always fully automated and in place. The industrial design of NovaSIP's filtration units provides several advantages. Standard chemicals such as sodium hydroxide, nitric acid, and sodium hypochlorite are sufficient, so you don't need to use other more expensive cleaning formulations. Chemicals can be partially recovered and recycled for further membrane cleaning. With a merry-go-round operation, you can isolate only the portion of the membrane unit that requires cleaning and keep the rest in production. On specific cases, you can also use a back pulse function in order to increase the production time between two cleanings. This function will be detailed in the next video tutorial. All these features allow to minimize cleaning cost and maximize time spent in production, thus maximizing productivity. Specific audit services can also be delivered by NovaSIP on a regular basis in order to make sure you're using all these great features at their full capacity. Do not hesitate to contact our filtration specialists for guidance on your piloting trials and for membrane cleaning optimization on industrial systems.